Welcome to the unit planning session. Now, we are going to watch this together and we're going to plan our unit plan together so that when you come into the actual session, you'll be able to have work time. So, we're going to talk a little bit about unit planning. Now, we're going to use Mike Metzger's Algebra 2 unit plan as an example. So, the first thing that you want to do with your unit plan is you want to figure out what is the unit that I'm going to be planning. So Mike is going to be planning for Algebra 2, and he's specifically going to be planning for quadratic equations. That's his first unit. So he's going to take the quadratic equation and he's going to try to figure out, okay, so I need to break the quadratic equation into unit goals. So he broke down his quadratic equation into 9 learning goals. And he's going to look the length of time that it's going to take for the quadratic equation. He says it's 20 blocks, which is a month. So notice that he broke it down. He broke the quadratic equation into 20 days, or an exact month. So when you're first planning a unit plan, the first thing that you have to do is you have to write your enduring understandings and essential questions. So what do I want students to understand as they learn the quadratic equation? And what are the essential questions my students absolutely have to answer about the quadratic equation? So Mike wrote for enduring understandings that students will understand that a term of a quadratic function determines its convexity, that the maximum of a concave profit function is the y-coordinate of the vertex, and that quadratic equations are the fundamental class of functions used to model projectiles. And the essential questions that students have to understand and answer as they leave the unit is, why can we find the maximum of a concave function and not a convex function? What is the sign of the A term effect, and how does that compare to the value of the A term? And why is the general maximum of constrained optimization functions of a regular polynomial? Those are the 3 essential questions that students absolutely have to leave his unit understanding. That's the first step. Then he goes ahead and writes his unit goal. The unit goal is, what will my students know and be able to do after this unit that they could not do before? And why does this unit actually matter to my students? So when you're writing your exam, you need to be able to come back to your unit goal and understand, what do I want kids to fully understand, and what do I want kids to fully answer? So you can read his unit goal later, but what I want you to see is this part. He says, by the end of this unit, students should be able to explain like a consultant how to model and solve nonlinear applied quadratic problems like optimization. I want you to notice this word, like a consultant. If he wants students to explain it like a consultant, then his exam needs to look a certain way. So Mike wants to ensure that he comes back to his unit goal when writing his exam. So the first thing he's going to do is write his enduring understandings and essential questions. Then he's going to write his unit goal. That's number 2. Step 3. He has to break apart the quadratic equation into what we call unit learning goals. So what are the main steps that students have to take to be able to master the quadratic equation? Mike broke it down into 9 clear steps. So I want you to see, I'm just going to read off a couple of them. The first learning goal is to compare relative magnitudes of functions and how they relate of change. He also writes that they have to find complex solutions of quadratic equations. He also writes that to be able to solve problems and equations that require the number system to be extended from real to complex numbers, because quadratic equations have both real numbers and complex numbers. Now, once he's broken the quadratic equation into 9 different learning goals, it doesn't matter how many learning goals you have. However many steps it takes to completely master the quadratic equation, that's what has to be included here. Now look down here. Mike includes above standards, A1 and A2. So he threw in these above standards, which are from which are from the AP Calculus exam, he wants students to be able to also answer these two standards. So he's pushing students a little bit even above the standard learning goals. Now notice he also put in here some spiraling skills. So these are skills that he may use for about 5 or 10 minutes as a do now, because students absolutely have to know these things to be able to do the quadratic equation. They have to be able to understand what decimals, investments, and radicals are. They need to divide decimals, they need to graph nonlinear functions, and they need to understand what prime factorization of numbers is. So he may do these for 5 or 10 minutes as his do now, but he included those in there because they're essential to the quadratic equation. So step 1 of writing a unit plan is writing the enduring understandings and the essential questions. Step 2 is writing the unit goal. Step 3 is then breaking apart the standard quadratic equations into the actual learning goals. And remember, the learning goals are the steps it's going to take for students to fully understand the quadratic equation. Then he's going to break apart the quadratic equations into knowledge and skills. What is the knowledge students have to know about the quadratic equation? And what are the skills students are going to need to do the quadratic equation? So again, I'm just going to read off a few of the knowledges. So the knowledge that students have to understand to do the quadratic equation are: they need to understand the convex functions have a positive a value. They need to understand that the solution of a quadratic equation are the input values in the domain and produce outputs of 0. So basically he's writing what is the knowledge that students have to understand to fully master the quadratic equation. He also put what is the vocabulary that students are going to need to know within this unit. And then he broke apart what are the skills that students have to master to do the quadratic equation. So they need to find the vertex of a quadratic. They need to determine if a quadratic is convex or concave, because that's going to also produce the maximum or the minimum. They need to understand how to factor a quadratic equation using the bottoms-up method. They need to understand how to simplify powers of complex numbers. So these are the certain skills that students are going to have as they master the quadratic equation. So let's go back again. If we're starting fresh, Unit 1, Mike has to write his enduring understandings and his essential questions. That is step 1. Step 2, writing the unit goal. Step 3, he's breaking apart the quadratic equation into unit goals. What are the steps it's going to take to fully understand the quadratic equation? Step 4 then is breaking apart the quadratic equation into knowledge and skills. And last, he's then going to actually map out the daily objectives into his whole unit. So he's going to take all of his unit goals and he's going to break them apart into days. So let's look here. It says find complex solutions for quadratic equations. That's going to take probably a couple days to fully understand. So he mapped it out. He mapped it out over here. Students will be able to differentiate between standard and vertex form. Then find the intercepts of a quadratic function is the next day. Then he's going to have them compare the range for projectiles launched at different angles. Then he's going to have them factor polynomials where a equals 1. So he took that one learning target and broke it up into 3 different days. So you want to take your learning targets and you want to see, okay, how long are they going to take students to fully understand? And you're going to break them up into different days, as Mike did here. Notice that the unit exam is going to be the last things that students will do in this unit. Now, backwards planning. I have to make my unit exam after I've mapped out all of my learning goals. I'm actually going to make my unit exam next before I ever even teach students, because if I make my unit exam, then I'm going to know exactly how to teach the differentiation between standard and vertex form, because I actually know exactly how I want students to answer it on the exam, because I have already written it. So let's show an example of this. Now, if I'm going to go ahead and pick an example. If I want students to differentiate between standard and vertex form, that's pretty simple. Let's pick another one. Students will be able to complete the square. If I want students to be able to complete the square, then I'm going to actually write, now I'm writing my exam. So exam number 1, unit 1, quadratic equations. So this is the quadratic equation, and I want students to actually solve by completing the square. So I have v squared plus 10v minus 21 is equal to 0. So I'm writing my exam now. And I got this question from a website called Kuta Software, which is great software, and I took this question. The question said, solve each equation by completing the square. So I went ahead and I copied and pasted this question onto my unit exam. And I thought, that's a little bit easy, just having students solve the quadratic equation by completing the square. So I'm going to now turn this question into a rigorous question. Instead of asking students just to solve, I'm going to say, use the following equation, which would be the equation up here, and find the volume of the cube by using the quadratic equation and completing the square. So now I want students to actually find the volume of the cube by using the quadratic equation and completing the square. So what are the steps that I want students to take? I want the students to actually write out the steps. So I would also include, please justify and write your steps as you solve or as you find the volume of the cube. So the reason why I put please justify is because I want to make sure that students know that they're actually going to solve by completing the square, then they're going to find v and they're going to plug v back in and figure out length times width times height. So they're going to do v squared, they're going to find 10v, and they're going to have a negative 21, and they're actually going to multiply all three of those and find the volume of this square. I want to make sure that students specifically know what they're doing. Now, if I have this type of question, then I want students to actually be doing this within my unit. So the reason why you're going to write your unit exam first is because then I know when I get to that day, so students will be able to complete the square, I know that I'm going to teach students how to complete the square and do a problem that looks like this. I might even have students do a hands-on project with finding the volume of this cube by completing the square, so that when it comes time for the exam, they're actually going to be able to master this question. So that's why we're going to write our exam first before we ever start teaching. Now, I'm going to leave with this. What you're going to do is this is the evaluative checklist for a rigorous unit. So once you're done with your unit, you want to make sure that you look at this checklist. So you have created learning goals that map a pathway towards rigorously meeting or exceeding the standard, specifically outline what students must know and be able to do, and contain a mastery threshold. You've designed a summative assessment that makes thinking visible, asks students to demonstrate what they are learning by solving interesting problems. So you have to write your summative assessment first. You've chosen rigorous learning material that has implicit meaning, ambiguity, layers, or complexity. You ask students to make meaning for themselves. You have selected rigorous instructional strategies that challenge students to use what they are learning in a meaningful way. So if you can check up all these boxes, You know,